Data handling using Numpy. Data and its purpose. Data can be defined as asymmetric record of a particular quantity. It is different values of that quantity represented together in a set. Data is a collection of facts and figures to be used for a specific purpose, such as survey or analysis. When data is arranged in an organized form, can be called information. Purpose of data: improve business performance, improve decision making, to find solutions of problems, to get a desired results, to perform various calculations, for analyzing various activities. Okay, structured and unstructured data. We can easily find structured data in our database system in the form of fields such as names, dates, address, etc. As the time goes by, people think how to handle unstructured data like text, image, videos, audios, etc. That might give you something useful to make decision in your business. What is data processing cycle? Data processing cycle is as the term suggests, a sequence of steps or a operation for the processing data. Processing raw data for the to the usable forms. The processing of data can be done by number of data processing methods. The stages of data processing: input. The raw data after collections needs to be feed in the cycle for processing. This is considered first steps called input. Processing: once the input is provided, the raw data is processed by suitable or selected processing method. This is the most important steps has to provide the processed data in the form of output, which will be used for further output. This is outcomes, and raw data provided in the first stage is now processed, and the data is useful and provides information and no longer called data. Stages of data processing cycle: input stage, data collection, data captures, encoding, data transformations, data communications, processing stage, output stage, and storage stage. Basic statistical methods for understanding data: mean, average, okay, then median, then mode, standard deviations, variance. Numpy. Numpy stands for numeric pythons or numerical pythons. Numpy is the package that contains several classes, functions, variables, etc. to deal with the scientific calculations in Python. Numpy is useful to create and process single and multi-dimensional arrays. In addition, Numpy contains a large libraries of mathematics like linear algebra functions and Fourier transformations. The array which are created using Numpy are called a n-dimensional arrays, where n can be any integer. If n is equal to 1, it represents one-dimensional array. If n is equal to 2, it represents a two-dimensional arrays. NumPy array can accept only one type of elements. We cannot store different data types into same arrays. Array structures in NumPy. First, 1D array, shape 4, axis 0. It's okay. 2D array, this is axis 0, axis 1, then 1, 2 rows, 3 columns. 3D array, okay, though axis 0 is 4 rows, and 3 columns, 1, 2, 3, and third dimension also is 2 columns, okay. So 4, 3, 2. Python NumPy. For working with NumPy, we should import the NumPy module into our program. Like following line of code is used to import the NumPy in the Python program. Import NumPy or import NumPy as name. Types of array in NumPy. Array in NumPy is the following types: 1D array, 2D array, n-dimensional array. 1D array. 1D array. One-dimensional array contains elements only in one dimensions. In other words, the shape of the NumPy array should be contained only one volume chapel. Array elements and array indexes, and this is the values. A simple program to implement one-dimensional arrays using NumPy. Import numpy.array 10, 20, 30, 40, print A. It is printing these values. Okay, now import NumPy as NP and np.array. This is also another method for alias name method. So np.array 10, 20, 30, 40 is print array. Okay, notice if you use the following statements, then there is no need to add anything in front of the array functions. From NumPy import star, then you no need to ask the NumPy here, because already is taken care of in the for statements. Okay, implementation of one array in NumPy. Creating array in NumPy can be done in several ways. Some of the important ways using array functions, use linspace, and third one is the arrange function. Fourth is using zeros and one functions. Using array functions. Using these functions, we can create an array of the data type. But if not data types is mentioned, the default data type will be the int. For example, from NumPy import star. array of 10, 20, 30, 40, 50, int is similar to array 10, 20, 30, 40. While creating array, if one values in the specified list belong to float, then all the values can be converted to float by default. From numpy import star a array equal to 10, 20, 40, this one. Then print a, all values will print with the floating point values. Now, linspace functions. The linspace function used to create an array with evenly spaced points between a starting and ending point. The following example demonstrates the use of the linspace functions. Linspace start n. Okay, now import numpy as np dot linspace 1, 10, 10. Then 10 element is created. 10 element is created. N is the number of values. 10 elements is created. Now I arrange functions. Arrange function in NumPy is the same as range functions in Python. The following format is used to create an array using the arrange function. Arrange start, step size. Arrange 10, then it generates 0 to 10, 0 to 9, and 5, 10, it generates 5 to 9, 5, 6, 7, 8, 9, 10, 1, minus 1, it generates the reverse values, 10, 9, 2, and import numpy. Okay, np dot arrange 10, arrange 5, 10, arrange 10, 1. Output will get like this. Okay, now creating an array using the ones and zeros functions. We can use the zeros functions to create an array with all zeros. The ones functions will be useful to create an array with all ones. They are written in the following: zeros, n, data type, ones, n, data type. Note, if the data type is missing, then the default value will be the float. Okay, example, zeros 5 will create an array with a 5 zeros values. The ones of 5 will create an array with a 1, 5, 1 values. Example, KP. Now KP is there, NP dot zeros 5 are equal to NP dot 0, 5. Okay, then it's representing the 0, 0, zeros, and this is ones. Okay. Next, mathematical operations in arrays. It is possible to perform a various mathematical operations like addition, subtraction, divisions, etc. on the elements of the array. The Now import np as np, k equal to np dot array 10, 20, 30, 40. Okay, now k equal to 5 plus 5, k plus 5, and print k, and k minus 5, print k star 5, print k divided by 5. We'll get these values. Okay, analyzes the array. Analyzes the array. Analyzes in array, it does not make any new copy. Make any new copy of the array defined earlier. It means new array created, only reference to the array of k. The following example demonstrates the use of the following: np dot array 5, 3, 4, 6, 7, 8, print k h equal to k, print h, print k. Okay, now k of 10, k of 0. Location I changed to 45, then print h and print k. So here also changed the h values. H values changed because of arrays. Now 45, 5 is there, kh, then print h also, printing the same value, and a k also changes, changing the reference. Copy method. The copy method is used to copy the content of one array to another array. The following function demonstrates the use of the copy method. Okay, np dot array 5, then printing, then k dot copy into the h, and print h and print k. If I change the values of 45, it won't affect any changes in the h values. H values it won't affect. Okay, two-dimensional arrays in NumPy. 2D array. The dimensions of the array represent the arrangement of the elements in the array. The elements are arranged horizontally, it is called row. And if the elements are arranged vertically, then it is called a column. When they contain only one row and one column of the elements, it is called a single dimensional array or one-dimensional array. One array contains more than one row and more than one column of the elements. It is called a two-dimensional array or 2D array. The following example used to demonstrate how to declare the two-dimensional array of the array using NumPy. Axis 1 and axis 0, 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. This is the index of the second array. Let us create a two-dimensional array in the NP. NP dot array 2, 4, 6, 6, 8, 10. Print x output 2, 6, 4, 6, 6, 8, 10. Endim attribute. Endim attribute used to refer the number of dimensions of the axis of the array. The number of dimensions is also known as the rank. The following example demonstrates the use of the engine attributes. Import numpy as np. np dot array 5, 6, 7, 8. np dot array 5, 4, 2 is two rows and three columns. A dot the endim size is one dimensional. Second is the two dimensional. Okay, shape attributes. The shape attributes gives the shape of the arrays. The shape is the tuple listing the number of elements along each dimension. The dimensions is called the axis. For one-dimensional array, it will display a single value, and a two-dimensional array, it will display the two values separated by the comma represented rows and columns. Okay, for example, import numpy as np. np dot array 1, 2, 3, 4. Print k dot shape and np dot a array 5, 6, 7, 7, 8, 9. Print d dot shape. Number of rows and columns in arrays. In array D, number of elements in array K. Output 5, 2, 3. Size attributes. Next is the size attribute. It will print the size of the array. Third one is the item size attributes. It gives memory size of the array elements in bytes. So here is giving the 4 bytes. Then reshape method. Next is the reshape method. It is reshaping 6 rows and 2 columns of this arrays. Next, empty function. So empty function is creating the empty values in your arrays. Empty values creating the function. Indexing in 2D dimension. Index represent a location numbers. The individual elements of an array can be accessed by specifying the location number of the row and a column of the array elements as follows. So this is the indexing findings A00, A01, A02. Okay, next slicing in array. Array names start, stop, and stepwise. The default value of the stepwise is 1. So here the values 0, 1, 2, 3 is a location, and this is a forward index, this is a backward index. Okay, so based on that, it will print with the slicing, it will print. Slicing in 2D array, row part and column part. Array name, this is a declaration. Start, stop, step size. Start, stop, step size. Okay, so this is some example. So slicings we can do. Next, I and the identity function. I functions create a 2D arrays and fills the elements in their diagonal with ones. I, n, comma, data type, t type equal to data type. So numpy dot I equal to 3. It is creating the diagonal 1. Next, zeros. Functions in 2D. Okay, zeros is creating with the integer, zeros is creating with the float. Next, one functions into the function will be used to create an array with a 1 as a default value for individual defined elements. For numpy ones, numpy ones is created with a 3, 2. It means 3 rows, 2 columns. Int 3 rows, 4 rows, 4 columns with a float. Joins in array using the concatenate H stack and a V stack, which is used for joining the arrays. Concurrent is used to join more than one array, but the array must be same type, same shape. Okay, this is joining. Next. Next is the H stack. H stack is used to join more than one array horizontally or row wise. Horizontally or row wise. V stack is used to join more than one array vertically or column wise. Next. Next array subset split and V splits. We can get a subset of numpy array by using one of the following. Okay, what is a split? Is to split a numpy array into equal or unequal parts. This is my split. So we're splitting into 3 ways: x1, x2, x3. This is a 3 elements. Next, H says split. It is used to provide subset of array after splitting it horizontally. So it is splitting the horizontal, left and right. Next, Y split. It is used to provide a subset of the array after splitting it vertically. It is splitting in the vertical model. Like this. This 2 rows, 4 columns. Okay, statistical function in NumPy: mean, standard deviation, variance, sum, prod, cumulative sum, and cumulative products. Min, max, returns the minimum and maximum of the array in the functions. So this is the example. Okay, next, covariance. Okay, covariance is a measure of how two variables vary together, like height of the persons and the weight of the persons in the populations. The covariance x, y of the random variable x, y is with an edge samples. Okay, this is the original array, and next is the covariance we are finding. Okay, this original array, the covariance matrix is a 2. That's it. Thank you. Thank you very much.